Okay, good day. This is AP Calculus Summer Review. I am Mr. McCulley, and this is SR4 Summer Review 4, and we are doing composition of functions today. All right, so we're going to talk about composing functions, and more importantly, we're going to talk about decomposing functions. This is something that we're going to use quite a bit over AP Calculus when we get to the chain rule. And so this is probably the one that we're going to use the most as far as our review stuff goes as we move into next year. So composition of functions is the process of combining two functions where one function is performed first and the result of which is substituted in the place of x in the other function. So our notation here is these two are equivalent, and I wrote them both down for you to see. This one we're going to use probably the most often, but you may see it f raised circle g of x, and in both instances the way you read both of these is f composed with g of x, or f of g of x. All right, so some examples of composition of functions is I'm going to say, all right, we're going to have three functions here. Our first function f is going to be x plus 3. Our second function g is going to be x squared. And our third function h is going to be sine x. So this one here, f composed with g of x, that means that we are going to do the inner function first. We're going to do this g of x first. So since g of x has been defined as x squared, I am going to replace this g of x with the x squared. So I'm going to get f of x squared. Now, the function f is defined as something plus 3. So it's going to be something plus 3. And in this particular instance, that something is x squared. So my final solution for f composed with g of x is just going to be x squared plus 3. Now, direction is important when composing functions. This g composed with f of x is similar to saying g composed with f of x. Now, f is this x plus 3 function. So I am going to replace f with the function x plus 3. Now g is the function something squared. That something is x plus 3. So we're going to take this x plus 3 and we're going to plug it in for x in this x squared. So it's going to become x plus 3 squared. Now, we need to multiply these out. X plus 3 times x plus 3 is going to be x squared plus 6x plus 9 when we distribute, when we multiply these two binomials. Now notice, composing f with g of x and g with f of x gives us two significantly different expressions. All right, finally, composing h with f of x. So this is the same as saying h of f of x. And remember that f of x is x plus 3. So we're going to replace f of x with that x plus 3. So I have h of x plus 3. And h is defined as sine x. So whatever I plug in for x, I'm going to replace it there. So again, I have a new expression that I'm plugging in. It's no longer x, it's the quantity x plus 3. So this is going to be, and these are equals all the way down. I suppose I should have all of them equals all the way down. At any rate, so I plug in my x plus 3 in for x in the sine function, and my final answer is going to be the sine of the quantity x plus 3. Now I can't reduce that any because you don't distribute sine. Sine is not multiplication, it's an operation unto itself. But this is going to be my final answer for this. Now, the process of decomposing functions. In calculus, it's going to be very important for us to be able to take a given function and see that it is the composition of two or more functions and be able to break these two functions, or these two or more functions, down into its component parts. So we came up with some functions that were compositions. We want to do that with these functions here. So our first one that we're going to want to try and decompose is f of x equals x plus 2 squared. Our second one, h of x equals 1 over the square root of x minus 4. And g of x equals the sine squared of 4x. Now, I have to admit, on most occasions, there are more than one way to do this. And you can do different ways and still get the right answer even when we're doing it in calculus when we get down the road. So when I look at this first function here, I see two functions. I see an inner function x plus 2, and then I see an outer function squared. So I am going to say that this is the composition of two functions, and I'm going to say my first function, I'm going to call it h of x. That is my inner function. That's my x plus 2. And then my g of x function, that is going to be my squared function. That's going to be my x squared. So I can say that f of x is equal to, now remember, if I were to plug in a number, the first thing that I would do is this x plus 2. So that's my inner function. So that's going to go on the inside of that composition. So if I were writing it, I would say g is the outer function. It's what I do second. So it's g of h of x, and that is going to be my composition of f. Now, when I come down here, I actually could have 2 or 3 functions, depending on how you look at it. Just because I want to do one that's a little more complex, I'm going to break this down into 3 functions. I see, and again, I'm going to work from the inside out. So what I do first, I plug in for my variable. What happens to it? I subtract 4. That's going to be my first function. So since I'm already using h, I'm going to use f for this one. I'm going to say f of x is this x minus 4 function. Let's get it right, minus 4. So that's my first function. Then what would I do? After I subtracted 4 from x, I would take the square root of that. So that's going to be my next function, my g of x. And so that function is just going to be square root of x. Then what would I do? Well, I'd go 1 divided by whatever that result is. So, excuse me, since I already used h, we'll use k of x is going to be 1 over x. So this is my set of decomposed functions. And so h of x, and again, I'm working from the innermost out. So my innermost one is f of x, and that thing is going to be composed with it's going to be composed with g of x, which is going to be composed with k of x. So I do the first thing, I subtract 4, then I do the second thing, take the square root, and then I do the third thing, 1 divided by that result. All right, last one. All right, so again, in this g function, I see essentially 3 functions composed together. I start in the innermost part. What happens to x once I plug the number in? If I'm starting to graph, I'm going to multiply by 4. So that's going to be my first function. So I'm going to say f of x. The first thing that I do to x is I multiply by 4. Well, what's the next thing I do? Well, is it sine or squared? Now, remember that sine squared x is the same as the sine of x quantity squared. So we want to make sure that we recognize that we would take the sine first before we do the square. So my next function, which I'm going to call h of x in this one, it's going to be the sine function, just sine of x. And then what do I do last? Well, now I'm going to square. So my k function in this particular instance is going to be just x squared. So my function g, composed of 3 simpler functions, is just going to be, I start on the inside, it's going to be f of x composed with, ooh, that was funky. G of x is going to be composed with h of x which is composed with k of x. So there's my decompositions. Oh, a short one today, only 10 minutes. Well, if you have any questions or if you feel that I made an algebra or arithmetic mistake, please feel free to give me an email and or leave a comment in the section below. And we are finished. So our Star Wars fun fact of the day. In A New Hope, Luke Skywalker's lightsaber, pictured here, is made from an old-time flash camera cylinder. So if you see one of those old-timey 1940s, 1950s cameras that the news guys made, the little flash handle. They took the little flash bulby part and they broke it off, and then they glued, and there's these black things, they glued cut up windshield wiper blades to the hilt. That's how they made that particular lightsaber. Oh, and these are lights from an old-timey calculator. But I just thought that was pretty cool. So I'm finished. You guys have a good day. That's a short one. I'm sure you'll be glad for it. Have a good one. Bye.